Okay, hello everybody. Well, here we are. I'm going to give you a brief introduction on how to carry out a titration, because it might be the first time you've used any of these apparatus, the kind of apparatus here which is really specific, volumetric apparatus for measuring accurate and precise volumes of liquids. Okay? You're carrying out a titration this week, if you're in the high level or the standard level class, to determine the number of moles of crystallization in oxalic acid. And to do that, we're going to carry out an acid-base titration, just a simple acid-base titration. Okay, you've got a piece of paper that tells you what to do. The first thing it asks you to do is to weigh out approximately 1.5 grams of the oxalic acid. I've done that already. Okay, I've measured approximately 1.5 grams into my weighing boat using a balance. But I do know precisely to 3 decimal places what the mass of both of these are, the weighing boat plus the acid. So the first thing I'm going to do with that is dissolve it in distilled water. I'm going to dissolve it in a clean beaker, first of all. Now that beaker needs to have been washed with some tap water and then finally rinse with some distilled water. And here's how I rinse with distilled water. Just turn it. I want to make sure that all the surfaces are coated with this distilled water. Okay? Doesn't need to be dry, because most of my solution is going to be distilled water. So the first thing I do is I tip that into here. Okay? Now, there may remain in my weighing boat some crystals of the oxalic acid. Well, you're going to just reweigh that so you've got the mass of the empty boat. You can subtract the two to find out how much acid you've actually added to here. Okay? It then says dissolve in distilled water and make up to 250. That doesn't work. I can't take the lid off. So I'm going to put in my beaker less than 250. Right? I've got about 150 mils of distilled water in there. And I'm looking around for a glass stirring rod, and I can't find any. Okay. With your glass stirring rod, you dissolve the solid into the distilled water. That's completely dissolved. The solid is very soluble. That's my glass stirring rod. Then you take your volumetric flask. Now these devices have a very precise and accurately known volume. Okay? This is 250 millilitres. Actually, we know that if we use this properly, we can measure 250.0 millilitres, or 250.0 cc's. Okay? So the first thing I'm going to do is transfer this into here using a funnel, a long stem funnel. This should be clean. Again, we should have cleaned it with 3 or 4 rinses of tap water, and then again rinsed it out with distilled water. We don't need to fill it with distilled water. We rinse it out. We make sure we've coated every surface, and then let that out. Remember, it doesn't need to be dry because it's going to be mostly water. Then hold the funnel up, don't let it sit down, otherwise you end up spilling. Hold it up a little bit and then pour your solution into here, like so. And again we are going to rinse. Remember, now there's some oxalic acid solution in here. So we have to wash our solution into here. Okay, we've got everything out of there. Just rinse that a little bit. Okay, and now we're going to make up. You'll see there's a gradation mark here. The bottom of our meniscus needs to be right on that gradation mark. And so we're going to do that. You might need to take out a teat pipette to help you do that, because if you go past, then you've completely messed up. And I've just messed up there. You can see that I've added more than the volume that I should have done because I'm rushing. So I've screwed up. I've got to start again. Okay? I'm not going to start again. If you do it, you will need to. We then put our ground glass stopper in, and to ensure proper mixing, we turn it over. A good 4 or 5 times, so we get a nice homogeneous solution. Okay, now then, if I've done that correctly, and if my meniscus is on the bottom of my line, I have 25.0 cc's of my solution with a precisely determined mass of oxalic acid in it. That means I can find the concentration of this solution accurately later on. Okay? This is my solution of the acid. It then tells me to pipette 25 cc's of 0.1 molar sodium hydroxide into a conical flask. Here's my conical flask. It's a 250 ml conical flask. And instead of pipetting out of this stock solution, this is my standard solution. This has got a concentration to 3 decimal places, or 3 significant figures. Knowing this concentration is going to allow us to find out the concentration of our acid solution. So, into my pre-labelled sodium hydroxide beaker with a nice pencil so we can rub it out, I'm going to put in more than my 25 mils. I've got about 100 mils of sodium hydroxide. This, by the way, should either be completely clean and dry, or, well, excuse me, it needs to be completely clean and dry. It cannot be wet, because otherwise we have then changed the concentration of the sodium hydroxide. My pipette now, this is a 25 milliliter pipette. Again, this, if we measure up to our gradation mark here with the meniscus on it, will have a precisely known volume of 25.00 cc's. 4 significant figures. Okay? This needs to be clean and dry, or it needs to have been washed with distilled water, tap water several times, distilled water, and then to get rid of the distilled water, we could wash it through with a little bit of our sodium hydroxide solution. I'm going to work on the premise that this is completely clean and dry. I'm going to not suck the sodium hydroxide into it like I was able to do when I was at school, but you have to use a pipette filler. Okay? The pipette filler, we roll up like this with one finger, and then we can let out liquid by pressing this. However, I'll show you a slightly different way. These have to be placed on the pipette. We hold the glass tube close to the end and place it on here. Okay? I urge you please to hold it like that, not like this, as you'll find that if you force this, this can snap, the glass can go into your vein here, and you can spread blood across the lab, and I don't want to have to clean up after you, so care. Okay, pull down, and then putting the tip of our pipette under the surface, but not on the floor, we bring the sodium hydroxide up. And I will always make sure it goes past the gradation mark, because then what I will do is very carefully slide my thumb up and put my thumb over the top. So I've now got just more than the 25. Evolution has created our thumbs with a thumbprint, which allows us to control the exit of water from here very carefully, drop by drop, until the bottom of my meniscus is right on the level. And I did that correctly. I'm then going to transfer my 25 cc's of sodium hydroxide into my conical flask. I'll just let that come out. The conical flask must be clean. It does not have to be dry. Okay? As long as it's been cleaned several times with tap water and then rinsed through with distilled water, we're fine. Now watch this next bit. If you look at the bottom of my pipette, you'll see there's a few drops in there. We are not required to blow those out or force them out. All I do is tip the surface of the liquid once, twice, and that withdraws most of it. And these pieces of apparatus are calibrated so that there's meant to be a drop left in. So I know now that I have added precisely 25.00 cc's of 0.100 molar sodium hydroxide to here.